Right now, 3i Atlas is displaying signs that have scientists questioning the very definition of a comet. New telescope data, strange movement, and chemical signatures never before seen in space have triggered a library of theories. Some of them go beyond anything. And the most shocking idea, that this might not be a natural object at all, but the question is, what if it was watching us? What if 3i Atlas is the first technosignature, a hint of alien engineering passing silently through our solar system? Let's explore the evidence, and you can decide for yourself. Every comet has a signature, a glowing trail of dust and gas stretching out like a celestial brushstroke. It's one of the few things in the chaotic universe that behaves predictably. Until now. When 3i Atlas was first observed, astronomers spotted something they couldn't quite explain. A tail that was pointing in the wrong direction. Instead of streaming away from the sun, as we'd expect from solar wind pressure, this tail, or what resembled a tail, appeared to be directed toward the sun. In cometary physics, this is nearly unheard of. It's called an anti-solar tail, and it's rare even among extreme outliers. Normally, the sun's radiation pushes gas and dust particles away from the nucleus, forming a tail that stretches behind it as the object moves. Think of it like a windsock blowing in the breeze. But 3i Atlas wasn't cooperating. Instead of being blown away by solar radiation, this tail seemed to be pushing into it, a kind of reversed emission, as if something was actively resisting the direction of solar wind. Now, you could argue that maybe it's a strange outgassing angle, perhaps something with the shape of the nucleus or uneven heating. And sure, that's possible. But what made this more unsettling is that the structure of the tail looked intentional, not chaotic, not scattered, just precise. Harvard astrophysicist Dr. Avi Loeb noticed it too. He suggested that what we were seeing could be more than just reflected dust. It might be a jet, a propulsion-like feature, or an exhaust stream. And while that sounds like science fiction, remember, science fiction often begins with a question we're afraid to ask. And what happened next only deepened the mystery. By September, astronomers received a surprise. The strange anti-tail had vanished, and now 3i Atlas sported a normal-looking tail, this time pointing away from the sun exactly the way a comet should behave. For most observers, this would seem like the story correcting itself. A glitch resolved. Nothing to see here. But Dr. Loeb didn't see it that way. In his recent review of the Keck 2 telescope images, he described the transformation as a black swan event. A sudden shift in behavior, not explained by existing comet models. And when black swans show up in data, they force us to reevaluate the entire system. Here's where things get weirder. This wasn't just a change in shape. The direction and structure of the emission shifted in a way that suggested an active response, not a passive one. Imagine a spacecraft firing a thruster to adjust its orientation. That's what this looked like. The tail didn't simply drift into alignment, it snapped into a new configuration. Some observers even described it as flipping over a short time span. Loeb theorized that this change might represent intentional maneuvering, like applying a braking thrust to slow down as it approached the sun. A comet doesn't do that. Let that sink in. A natural object doesn't slow itself down mid-flight, unless some very specific and rare sublimation dynamics are in play, none of which were observed here. And then came the most compelling detail. This tail flip coincided with the object entering a position where sunlight could maximize pressure against the core, and instead of pushing it, it steadied. Could that stability and the precise change in orientation point to an underlying control mechanism? We don't know yet, but when physics bends like this, it usually means we're missing a piece of the puzzle. Now let's get to the chemistry, because this is where things get unsettling. Comets are typically dusty snowballs, frozen water, rock, and simple carbon compounds. As they near the sun, that icy shell vaporizes, releasing gas and forming the coma and tail. But 3i Atlas isn't doing that. Instead of the usual suspects, like water vapor or carbon dioxide, scientists detected a focused jet of gas aimed straight toward the sun. Again, that's backwards. No dust-driven tail, no visible signs of chaotic disintegration, just controlled emission. Even stranger, the gas plume contained a compound never before seen in any known comet, nickel tetracarbonyl. Let's be clear, this is not just a rare molecule. It's a toxic industrial chemical, a volatile metal carbonyl that breaks down easily under UV light, releasing nickel. It's something humans manufacture in metal refineries and use in high-performance engines. Now imagine finding it 200 million kilometers from Earth, in the coma of an object from another star system. That's what scientists saw, nickel compounds actively breaking down in the presence of sunlight, releasing steady streams of gas into space. It didn't appear to be random, it seemed coordinated. Loeb even suggested this could be a kind of thermal exhaust, a byproduct of internal systems reacting to solar heating, or even deliberately using solar energy to navigate. If that sounds far-fetched, let's flip the question. If you were an advanced civilization sending probes across the galaxy, wouldn't you build them to harvest solar power? Wouldn't you equip them to adjust course using sunlight and ejected gas? That's not fiction, that's basic engineering. So if 3I Atlas is natural, how is it mimicking the precise emission patterns we associate with engines? Because what we're seeing here is not just a comet doing something unusual, it's a comet doing things that look deliberate. According to a joint theory by Dr. Loeb and orbital dynamicist Adam Hibbard, 3I Atlas might be using braking thrust to slow down as it approaches perihelion. Why would it do that? Simple, to establish a stable orbit right between Mars and Jupiter. In other words, to stay here. That corridor, the asteroid belt, is one of the most resource-rich and observationally favorable regions in the solar system. From that vantage point, a probe could monitor planetary motion, solar cycles, even Earth. And if it slowed itself down just enough, it could lurk there indefinitely. That's where this theory crosses into unnerving territory. Because if 3I Atlas is maneuvering, it's not just visiting, it's watching. Mark your calendars. On October 29, 2025, 3I Atlas will reach its closest point to the Sun, a distance of 1.36 AU or roughly 203 million kilometers. At that range, it'll absorb nearly 33 gigawatts of solar power. That's enough energy to boil oceans if, say, you had an ocean nearby. Already, new images show material streaming out behind the object, but the question remains, is that natural vaporization from sunlight or something else? We'll soon find out. Naturally, this has triggered a debate among experts. On one side, you have Avi Loeb and his collaborators, who say we must take the artificial origin theory seriously. They point to structured emissions, non-random trajectory, and the industrial-like compounds. On the other, mainstream astronomers insist that 3I Atlas is strange, yes, but still within the realm of exotic comet behavior. NASA has publicly stated that the object poses no threat to Earth and is likely just passing through. But here's the thing, official silence doesn't kill curiosity, it fuels it. And that curiosity is turning into public demand for answers. Astrophysicists, amateur astronomers, even engineers are debating the object on social media, asking the same question. If this isn't a comet, what is it? The International Asteroid Warning Network has quietly added 3I Atlas to its long-term observation list. That's not standard practice. The reason? It's unusually long visibility from Earth and unpredictable behavior. The object is being tracked across multiple continents by coordinated observatories. This kind of sustained global monitoring usually precedes one of two things: a close Earth approach, which this isn't, a discovery that could change how we think about our place in the universe. So, which one is this? Let's entertain the possibility, just for a moment, that Loeb is right, that 3I Atlas isn't just strange, but designed. That it's a probe, maybe automated, maybe ancient, maybe activated by proximity to sunlight, maybe recording everything it sees. What would that mean? It would mean we're not alone, that we're being observed, not attacked, not contacted, but simply studied. Maybe it's like our Voyager spacecraft, sent to map, measure, and move on. Or maybe it's waiting for the right signal or the right moment to reveal more. Now, to be fair, natural explanations still exist. Some suggest the anti-tail was just an optical illusion caused by the viewing angle. Others argue that outgassing patterns can shift over time, making the tail appear reversed. And the nickel compound may be a rare chemical reaction triggered by intense solar heat. Let's step back. Across cultures, across centuries, humans have always asked the same question. Are we alone? Oumuamua sparked this conversation in 2017. Now 3i Atlas is reviving it and maybe pushing it further. Because this object isn't just passing through. It might be slowing down, changing direction, adjusting trajectory. And if it is, that raises the biggest question of all. Is Earth being watched? And if so, for how long? The next few weeks are crucial. As 3i Atlas approaches perihelion, new data will come in. Telescopes around the world will be focused on this visitor, capturing every flicker of light, every movement, every clue.